Hi everyone, it's me, Carolyn, again, and I am going to talk a little bit about the standard normal in this video. And I will go to StatCrunch as well at the end of this video to show you how we can get the same results. I will do so in two methods. First method is I will do some of these problems using a table, and then I will go to StatCrunch so you can see how those are done as well, that direction. So most people did not have StatCrunch in the old days 5 years ago. So we did use tables. But first of all, the standard normal. I want to draw a little picture, which is down here. Just kind of remind you, the normal curve is our bell curve. It is nice and symmetric. The properties of this standard normal. It is symmetric, so again, nice and even on both sides. The mean is 0, so that means it's going to be centered around 0. And we made it to have a standard deviation of 1. The mean, the median, and the mode are all 0, remembering the highest, think of 100 people sitting underneath this curve representing our population. We have most of them in the middle, because that's the highest point. That's our mean. Our median, our mode, it is nice and symmetric, so our mean is going to be there. And also, since it is symmetric, the middle is in that same spot. The inflection points, which is where it kind of turns from being bowl-shaped down, so kind of curved down, to being curved up, is called an inflection point, and that happens 1 standard deviation away from the mean. In the case of the standard normal, that's at 1 and -1. This should just be the number 1 here. Since this does represent a probability distribution, the area under this total curve, so if I shaded this entire thing and found the area under that infinite curve, it turns out to be 1. It is symmetric, so everything that's on this side is the same as on this side. So we have half of our data up there and half of our data down there. So that's kind of what this says in words. Also, as our Z, we like to use Z for the standard normal instead of an X. As it gets larger and larger, the graph is still positive, but it's not very high off that axis. And I also want to remind us that the empirical rule does still hold. So if I go up 1 standard deviation and down 1 standard deviation, which means between -1 and 1, we get 68% of our data. If we go between 2 standard deviations, so up 2 and down 2, so between -2 and 2, we have 95%. And 99.7% is between -3 and 3. However, in the real world, we are very rarely at those 1 standard deviation away, 2 standard deviations away, or 3 standard deviations away. We could be anywhere, and we want to be able to answer questions about any situation. So that's why we do a little bit more in-depth look at the standard normal and, in fact, the normal curve in general. So let's just concentrate, though, in this first video on that standard normal curve and just how to find different probabilities. So remembering the standard normal curve is a probability distribution. So we use the letter Z, centered at 0. Standard deviation is 1. And let's just say I want to find the area. And the area under the curve. And let's go to the left of 1.33. Now let that equal my Z value. Okay. And we do again use the letter Z to represent our standard normal. We like to use the letter X for any particular situation that we're dealing with, some general normal curve, but once we standardize it, we like to use the letter Z. And so in terms of my picture, what I'm trying to find, so here's 0. So that means 1.33 would be here. And I'm just going to draw a line. And we want to find the area to the left. So that means I want to find out what this area is. Okay. Another way to ask that exact same question, because remembering that the area under these curves also represents probabilities. So I could have asked myself a question, what is the probability that Z, because we're talking about the standard normal, is less than or equal to 1.33? We are in a continuous situation. So the fact that we have an equal to here, or whether we don't have that equal to, is going to be the same result, because the probability that it's exactly 1.33 is 0. Now to find this, we're going to be using what I'm going to show first of all is table. And this table, there's a couple different tables out there. I did take this one right from the textbook that this particular class is using by Michael Sullivan. But there's two basic tables, and this one happens to be a cumulative table. And what it does is it gives us areas to the left of a certain value. And it usually is a two-sided table. One side, you'll notice we have a Z value here. They're going down. We started about negative 3.4 something. And then on the other side, we have our positive results. So our Z values are going to be going across this side as well as across the top. Okay, across the top is going to give us that 100th spot. So for this particular example, we're going to be looking for that 1.33. So we go down our column here, 1.3, and then over to the 3. So this is like the Z is equal to 1.33. This is the area to the left of that value. So 0.9082. 0.9082. Okay, I'm going to do another one. We're going to find the probability that is less than a negative 1.85. Okay, I like to draw pictures just so I can understand what is going on. And so here again, standard normal is centered at 0. So I always kind of put in my 0 as a reference point. A negative 1.85 is on this side, because negative is to the left of the 0. And I want to go smaller than it. So we're looking for the area of that little tail. Okay. So again, I'm going to use my table and looking at the negative 1.85. So down here is my negative 1.8. I need the 5 from across the top. So negative 1.85 is 0.0322. 0.0322. I will show you how to do this using StatCrunch as well, but I do want to make sure that we can use table because who knows if you'll have StatCrunch in the future. And yeah, or you might pick up a different book or a different situation, and kind of being aware of what's going on sometimes makes a difference. Also want to point out that we did get an answer that was bigger than half here, because I want to remind us that everything from 0 down or 0 up, because that's the middle, divides it into half. There's 0.5 above and 0.5 below. So us having a value that's less than 0.5 makes a lot of sense. All right. Let's do something a little different here. Let's do Z greater than 1. Let's go 0.2. All right. I'm going to draw a picture. And there are a couple of ways to do this problem when I'm using the table. Again, I always like to draw pictures to help me so I can visualize it. 1.02 is over here somewhere. My pictures are never to scale. They're just there for reference. I put the 0 there as the middle, a positive number to the right, negative numbers to the left. And then I want to go above. So I'm going to go this direction. Okay. Again, I'm going to do this one a couple of different ways. So I'm going to look up that 1.02. So I'm going to be on my positive side. 1.02. That gives me 0.8461. So I looked up 1.02. That gave me 0.8. Find again. 461. But now remembering that this gives me from that point down. So that gives me this guy here. This is where we can use the idea that the total area under the curve is equal to 1. So I can subtract and come up with 0.1539. I hopefully subtracted correctly. I believe so. You could also use the idea of symmetry because this is nice and symmetric. So if I flip this onto this side and I looked at the 1.02, the negative side, there's that 1539, which is what I had here. So we can use symmetry, or we could use the idea that the entire area is equal to 1 to get our values. Okay. The last one I want to talk about is, let's say that we do between two values. I'm actually going to do 2 of these so that we can just say, oh yeah, that makes sense. So if I want to find the value that z is, let's go negative, let's just go, doesn't have to be negative and positive. Let's go 1.17, that our z is between those two. Okay. And again, once we get to StatCrunch, we will find that it is a lot easier. But I still sometimes like to draw my pictures so that we can understand what is going on. We're finding the area between these two. So 0 is here. I chose a 1.17 here, and 2.23 is there. We're finding the area between those two. Okay, and again, I'm going to use my table, and we will go between those two. So I'm going to find my 1.17, 1.1, I'm just looking that up, is 0.8790, 0.8790. Just going to double check here. 1.178790, and I'm also going to look up 2.23. 2.23. And then I'm going to use the idea of what these numbers represent. 2.29871. 0.9871. Okay. Now remembering what the table tells us, and I'm going to pull a couple different colors. This tells us this 8790 is the area to the left of this one. So I'm going to kind of just say this guy right here. So this is 0.8790. Or if you want to think of it in terms of percentages, that's 87.9% of our data is smaller than that 1.17. This guy is from this point all the way down, so to the left. So 0.98 0.971. Okay, so to find between the two, what we're going to do is take the larger area and subtract off this piece here because that's not included. So we're going to subtract those two. So 0.9871 and subtract 0.8790. That's going to give me 181. Okay. And we can do that as well with 2 and -2, and we would find that it should be, again, remember, up 2 standard deviations and down 2 standard deviations should be roughly 95% of our data. So let's draw a little picture. Okay, there's my 0. And we're going to go between -2 and +2. So we should get 95%, right? According to our empirical rule. So I'm trying to find the probability that we are between -2 and +2. And whether I include those values or not include those values at 2 and -2 will not make a difference. All right, so I'm going to look up the -2 to get this little bitty area down here. So -2, and I want to do is 2.00. That's 0.0228. So I'll put that one here. 0.0228. I'm going to look up the +2, which will go from this guy all the way down. So this is 0.0228. +2 is on my other side. 0.9772. 0.9772. 0.9772. So to find between these, I'm going to take this guy here and subtract that one off, and that'll give me what's left. If I subtract, we'll see a 0.9544. Notice it is not exactly 95%. It's actually 95.44%. And to be honest, the table is actually more accurate than the empirical rule. That's why in the empirical rule, it says roughly 68%, roughly 95%, roughly 99.7, or approximately, depending on which version of the empirical rule you're reading. Okay. Another thing that we sometimes do, just so that you are aware, we have some notation. We will use this little z, a little subscript called an alpha. Now this alpha you will see a lot in the future when we get into some of the other pieces of statistics. And this is actually, we're going to be looking for a certain z value. So we're going to be looking for a value that is here. Doing this in StatCrunch is sometimes a little easier than it is doing it on the tables, but I want you to understand what you're finding. So I'm going to look at, so let's just, for example, find a z.05. Okay, what this represents is, okay, my standard normal, z is our standard normal, centered at 0, standard deviation of 1. This is going to represent the area in an upper tail. So this is going to be that 0.05. So that alpha is going to be the area of an upper tail. Okay, and what we want to do is we want to find the z value that gives us that little bitty area. This is going to be our z.05. Okay. To do this on our tables, we need to find the area of 0.05. Well, our area on our table is always to the left. So we have to do a little bit of math. If this is 0.05 up here, the rest of it, remembering 1 is under the entire thing, this is 0.95. Okay, and I realize that since this is more than half, we're going to be on the upper side, so Z is going to be a positive number. And I'm going to be looking for 0.95 as an area. So inside here, as close as I possibly can get. When we get to StatCrunch in just a few moments, we'll be able to get it a little bit more exact than what I can find. Okay, so 0.95, here's 92, 93, 94, oh, here's 956 something. I want to go backwards. Okay, so it's going to be in here. There's a 947, 948, 949. So it looks like it is smack dab between these two values. If we were doing these problems using just the table, we would actually pick the one that's closer. Okay, so we would look at these two numbers and say, okay, which is closer? And then we would go with that Z value. Since these two are exactly the same distance apart, we will split the difference. So my Z value is going to be 1.6. And I come up here to form my next digit. And if I had this one were closer, I'd pick the 4. But I want to go halfway between those two, so I'm going to actually go 1.645. So my Z here is going to be 1.645. Okay. I'm going to do another one. Let's do Z.1. Okay, going to kind of use my picture above. So 0.1 is going to represent the area in this little tail, which means this is going to be just 0.9. So I'm going to be looking for 0.9 here. So I see 0.90, 0.825, 89, 896, 8980. So it looks like in between these two, and it looks like this guy here, that 0.8997 is actually closer than this one. Only 3 away here. Here I'm a little bit too big. So I'm going to go with this one. That's going to be a 1.28. 1.28. Okay. So again, just some notation. All right, now I'm going to go and take these values that we just did. We're going to go and actually calculate these again. So I'm hoping you can have written them down or something of that nature. So we're going to do less than 1.33, less than this guy. And we're going to do these again, but we're going to do them in StatCrunch. So I'm going to stop sharing my screen here. Okay, so you get to see me. And I'm going to go to StatCrunch. Okay, you should be able to see StatCrunch now. And we're going to be using, again, some of our calculators. So we're going to go under statistics, that's stat. We're going to go to calculators again. We did this for our binomial. We did this for the Poisson. We're going to do this as well for the normal curve. And we're going to go straight down to normal. So there it is sitting there. Okay. And we are doing, oops, the standard normal. So we want to make sure to put in our mean of 0, standard deviation of 1. It does draw a beautiful picture here. For that very first problem, we wanted less than or equal to, again, notice it does not give us the two options of just less than or less than and equal to, because they are the same. But we wanted to do less than 1.33. So I'm going to type in 1.33 and I'll hit my compute. And you'll notice we do get a lot more digits than the calculator gave or the table gave us. So 0.908 2 is what we had. Notice it also draws a nice picture for us showing that red. Okay, so using StatCrunch again, we went to stats, calculators to normal, brings up this table here. Our other one that we did is we did less than a negative 1.85. And we have that 0.0322. Notice I'd have to round a little bit because StatCrunch does give me more digits. So make sure you're following what the directions of your problems tell you to do. And so there's my negative 1.85. We're going smaller than it. Okay. Our next problem, we actually did a greater than. And the nice thing about StatCrunch is it does allow us to go either above or below. And here we did 1.02. So 1.02. We got 1539 after doing some subtraction. And there's our 153, and we would round that to 9. Again, I did this one 2 different ways. We kind of used the symmetry, and we looked at the negative, or we did from that point down and subtracted from 1. But again, StatCrunch does a much nicer, quicker job for us. And to be honest, StatCrunch probably uses just a more in-detailed formula or table than we have. So it's giving us more digits. To do something for between, so this is how we would do above and below. If we want to do between, we actually have to switch to from the standard to the between button. And again, still make sure our mean is 0, standard deviation is 1. And we want to go between 1.17, and we did 2.23. 2.23, and we got the value of 0.1081, and there's our 0.1081. We had to do 2 separate values and subtract. StatCrunch does it directly for us. Okay. If you want to see the empirical rule, if I go between -2 and just 2, there's our roughly 95%. If you go between -1 and 1, you'll get roughly 68%, and so forth. Now, to find our z with that little subscript alpha, okay, I'm going to go back to our standard. Here, we're trying to force the area to be a certain value. So we're going to be changing this piece at the end, and we're going to be looking for what that upper piece is. So we want to put, like for that first one, we did 0.05, and we want x to be larger than something, to be 0.05. We got it to be 1.645 because it was right between those 2 values. So I'm going to compute, and you notice there's my 1.6448, which if we went to 3 decimals, 1.645. We did another one to be 0.1. We can compute, and we had that 1.28 because it was closer to the 8 than it was the 9. And again, it's showing you a picture. So this is your value here, that 1.28 is the number down on the scale. That's our x. It should be a z for the standard normal. I wish it would change to a z for your standard normal. But this one is set up to deal with any normal curve. The red shaded region, that area of that curve, is that final result. So hopefully that helps you get a nice idea of the standard normal. In my next video, I'm going to take a regular normal curve, and we are going to do some regular problems and try to figure out how to do, how do we get the connection between a real world type problem and what we just did here. Again, StatCrunch does all the work for us, but sometimes I feel it helps to see where these things come from. But I'm going to stop sharing. And I'm going to tell you to have a great day, and I will see you in my next video.